I want to give you guys a couple of facts. And from those facts, I want you to create a polynomial. Well, guys, if you go back to the day where I said I was going to show you guys how to cheat, right? We took roots. From those roots, we made factors. From those factors, we made polynomials. And that's exactly what we're going to do here, okay? So I want to create a quadratic that has roots of -3 and 4. All right, so let's go to my graph. I want to have a root of -3 and 4. Now, what is the other piece of information that they give me? I want it to be a quadratic function, which means what needs to be in it? An x squared. All right, well, guys, think back to the lesson from a couple days ago. If I tell you that one of the roots is this, and the other root is this, how can I work backwards? I want them to be equal to 0, right? So what am I going to do with the -3? Yeah, so I'm going to add, yeah, you're right. I'm going to add the 3, right? I'm going to move the 3 over here. So it's going to say what? It's going to say x plus 3 equals 0, right? And then what am I going to do here? Well, I'm going to subtract the 4. And it's going to say x minus 4 equals 0. So do we know what the factors were that created this polynomial? Yeah, one's x plus 3, the other is what? X minus 4. So I know that this times this gives me the polynomial of interest, right? Guys, what if I want to go one more step back to the original? What do I need to do with these two things? Multiply. So if you want to play tic-tac-toe, right? You can play tic-tac-toe. I'm going to move quickly here. So if we played tic-tac-toe, we would get this. So this is a quadratic with roots of -3 and 4. Everybody good with that step? All right. And again, we've already sort of done that, right? Not new at all. Okay. But there is one other fact that we have to take into consideration. And the other fact is this. I need my quadratic to go through that point. 2, -50. 2, -50. So this is what my quadratic should ultimately look like. Whoa. Sort of. That's a pretty bad picture, but you get the idea, right? It's going to look something like that. Do I know for a fact, guys, that this quadratic goes through this point? Do I know that right now? You think Gavin's shaking his head no. In fact, if I take x squared x squared minus x minus 12 and I go to the table, where am I at 2? I'm at -10, right? So the quadratic that we created, Trinity, that has these two roots, does not go through this point, does it? Right? It goes through the point 2, -10. Quick question, what would I have to do to -10 for it to go through the point that I want it to go through? Multiply it by what? Multiply it by 5, right? Well, watch this. So if I was to take my problem and distribute the 5, I get that. So here's my question. Ready? Did that screw up the roots? Does that screw up the roots? By me multiplying by 5, so it goes through that point. Does that screw up the roots? So I hear some people say, yeah. I'm seeing lots of people shake their head no, but I kind of want a reason why. Why will that not screw up the roots? It's kind of an abstract concept, but why do you think? Because I multiplied everything by 5. So what would be the reverse of multiplying everything by 5? Taking everything out by 5. So by doing this, by multiplying everything by 5, do you agree that this has a GCF of 5 now? Yeah. And doesn't it still have these two roots? Yeah. So does 5 mess everything up? No. In fact, I can multiply by values like that and keep the roots the same. So when we do these types of problems, we always have to get the roots first and then adjust the equation after we have the roots. Okay? Do another one. All right. Consider the following polynomial. Boom. What does it say about A? Well, it says A can't be 0. So A has some value, doesn't it? Okay, do we know what A is? No. Do we care what A is right now? No, because the first question says, what are the x-intercepts? Well, how do I get the roots? I set the factors equal to 0. But can A equal 0? No, because what does it say right here? It can equal 0. Okay, so that doesn't work. So I have a root of -2. And I have a root of 5. Now, really quickly, guys, those are not really the way that we write roots. How do we write down a root? We write it down as a point, Jaden, right? So instead of saying x equals -2, I would say the root is -2, 0. And instead of saying x equals 5, I would say it's 5, 0, right? So these are my roots. Use your calculator to sketch and label on the axes given the following equations. So guys, what am I doing here? I have the exact same factors, right? Except what am I doing with my A's? I have an A of 1, an A of 2, and an A of 4, right? And so what do you think this is going to prove to you? It's going to prove to you what I just explained, right? The A value will not do what? Change the roots. So watch, this is the proof of that, okay? So if my A value is just 1, then I have, what were those factors? X plus 2 and x minus 5. So watch what this is. You don't have to do anything, guys. Just watch, right? So here's my parabola, right? Root of -2, root of 5. Everybody's good with that? All right, so watch what happens. Instead of having a 1 here, I'm going to make it a 2. And what happens? The roots are the same, right? The graph is maybe a little squished, right? In fact, if I throw a 5 on here instead of a 2, then it even gets more squished, right? Or stretched vertically, okay? But you notice that the roots don't change. Hey, what if I threw a negative sign in the front? What if I threw a negative sign in the front? It's going to be upside down, isn't it? Yeah, is it still going to have the same roots? It should, right? And so you can tell by the way it's shaped, right, that it's actually going to go this way now because it's, you can, maybe you can't tell. Can you tell? Yeah, if I really want to emphasize that, what if I did like -1, and then you can really see it'll widen it out a little bit. Okay, so the A value does not matter in terms of the roots, does it? Okay. All right, skip past that. All right, so I can make these a little bit more challenging, not all that much more challenging, but a little bit, right? What do I say? I say that these are the roots, right? I have a root of -4. I have a root of 2. I have a root of 5, correct? So if those are my roots, what are my factors that create those? Well, if I add 4, I get x plus 4. If I subtract 2, I get x minus 2. If I subtract 5, I get x minus 5. So how many factors do I have? 3. So I'm going to take those factors and write them as a product. Okay, so what did I have to do in the last example? I have to take these 3 things and multiply them, right? I have to multiply them. Can I multiply 3 things at the same time? No. But I can do 2 of them, get a result, and then multiply that by the 3rd thing, right? So what am I going to do? I could play tic-tac-toe with this, right? Or I could FOIL it. I'm just gonna FOIL this one, and then we'll play tic-tac-toe together, okay? So if I multiply these 2 together, I would get x squared plus 2x minus 8. So now I want to multiply these 2 things together, right? Because it's 4x and -2x. Got it? How many things do I have here? 3. How many things do I have here? 2. So if I play tic-tac-toe, it's going to be what? 3 lines and 2 lines. Oh my gosh, that looks terrible. All right, so what do I get? I'm moving quickly through this because at this point in the game, guys, I know that you can do this skill. All right, so what did this say? It said create the equation, right? So my equation is y equals x cubed minus 3x squared, combined like terms, Trinity, right? Minus 18x plus 40. All right, so to summarize, guys, what did I do right there? That is the is that a quadratic? Is it a quadratic? No, because it's what? It's a cube function, right? Okay, so here's the question. The question is, that is the quadratic that has those particular roots, right? Okay, do I know if it goes through the point of interest? What was the point of interest? It said that I want to go through the point 620. So what am I going to do? I'm going to look at my calculator. I'm going to see what point I actually am going through, right? So I'm going to plug this into my calculator. X cubed minus 3x squared x cubed minus 3x squared minus 18x plus 40. All right, got that. And why did I put that in the calculator again? Because I want to know what point I'm going through at 6, right? And go to my table. And let's see what happens. At 6, I'm going through 40, right? So on this function goes through the point 640. What did I want to go through? 620. So what do I need to do to this function so that I can make it go through 620 instead of 640? Divide it all by 2. So my correct function now does what I want. You got it. Yep. So again, Trinity, this is the one that has the correct roots, right? This is the one that has the correct roots and goes through that special point. Okay? So you do the roots first, we do the special point second. All right? Create the equation of a cubic. So if I say cubic, how many roots should I have? 3. That has a double zero at -2. A double zero is what kind of a root? Bounce root. Yep, it's going to bounce. And another 0 at 4. All right, what am I going to do? I'm going to get each of those equal to 0 and then write my factors out, right? So I'm going to have x plus 2 equals 0. I'm going to have another x plus 2 equals 0. And an x minus 4 that equals 0. That makes sense because 3 factors will give me a cubic, won't it? So I have x plus 2 times x plus 2 times x minus 4. All right, I'll save you the trouble. This is going to give me x squared plus 4x plus 4. And Blake, I'm going to play a little tic-tac-toe again, right? Because I have 3 items times 2 items. So right now, my equation gives me that. What happened right there, guys? The 4x squared, the negative 4x squared, what? Cancel each other out, right? It's negative 16x and 4x is negative 12x. I got this negative 16 at the end, right? Again, what is this? This is the quadratic that has the appropriate or the correct roots, right? This has the correct roots. Does it go through the point of interest? Because there was one other thing that we went by. It said that I need to have a y-intercept of 16. What's the y-intercept right now? Negative 16. What can I do to make it positive? Multiply everything by a negative 1. So my correct response would be negative 1 times this. All right. Of course, guys, if you wanted to distribute the negative 1, you could, right? Or you could just leave it like that. Right. So besides that last step, guys, where you had to account for the special point, the process is kind of like what we did the other day, isn't it? Where we work backwards. Everybody okay with that? All right. All right, the last piece, guys, that we're going to pick up on today is the remainder theorem. And again, guys, like I promised you, I thought that last piece that we did was an extension on something that we did earlier. And this is an extension on what we did yesterday, okay? So here's what I want to know. It says, in each of the following, I have a polynomial divided by some denominator. Consider each of the scenarios. What conclusion can we draw? So all we're going to do here, guys, is I want to know, is the denominator a factor of the numerator or not? Okay? So yesterday we learned a shortcut method, and that shortcut method was called what? synthetic division. And what did I need to do to use synthetic division? Well, I had to put the root of the denominator in the box, the special box, right? So what is the root of the denominator? X minus 2 equals 0. So this says x minus 2, right? I'm looking for the root of x minus 2. 2, yeah. Yep. And again, that is the root of x minus 2. And then I look at what I'm dividing into, right? What's the degree of what I'm dividing into? Degree 2, right? So I need the degree 2 term, I need the degree 1 term, and I need the constant. Are they all there? Okay, good. So what are the coefficients? I have a 1, I have a negative 8, I have a 1, I have a negative 8, I have an 18. And then I need to remember to do what with the 1? It comes down, right? And then I flip-flop what two operations? Multiplying and addition, right? So what goes underneath the negative 8? 1 times 2, right? So this is a 2. What's negative 8 plus 2? Negative 6. What's negative 6 times 2? Negative 12. And what's 18 plus negative 12? 6. So what did I get as a remainder? That's the remainder, right? So what conclusion can you draw? X minus 2 is what? Not a factor of that. And the remainder theorem says because the remainder was not equal to 0. And the way that you would think about that in your head is because 5 goes into 40 8 times and is a factor, 5 goes into 41 8 times but has a remainder, so it's not a factor. What goes in the special box? 7. Do I have all the terms that I need? Don't use the word flip the sign, use the word get a root. Because there are some cases where we'll get there. Do I have all the terms up top? So I have a 1, I have a negative 2, and I have a negative 25. So I have a 7, I have a 5, I have a 35, I have a 10. X minus 7 is not a root of this. How I got this 7? 1 times 7. Up here, 1 times 2 is negative 6 when I add these together. Negative 6 times 2 is negative 12.
What's the difference between root and factor?
A root is what you get when you set a factor.
Yeah, but you said factor up there. You said x minus 2 isn't a factor of x.
Correct. Because this did not what? Divide into that evenly.
Yeah, but now you're saying x minus 7 is not a root. Like what?
Oh, sorry. Okay. I'm actually glad I made that mistake. I wanted to write the word factor. Okay. But to answer your question, Giuliani, if x minus 7 is not a factor of this, then 7 is not a root of that. Correct?
I understand that part.
Yeah.
I was just like mixed up with
Yeah, I should have wrote the word factor. Yep. So if x minus 7 is not a factor, then 7 is not a root. Okay. What goes in the box? What's the degree of the top? 2. So I need 3 terms. What are the terms? 2, 11, and 11. Down comes the 2. Gives me -6, gives me 5, gives me -15, gives me -4. And so again,
No, hold on.
all right, so we have 3 cases, guys, where the denominator is not a factor, okay? And that's, again, because we got remainders of not equal to 0. Can I flip it? So here's how this is going to work, guys. I really want you to actually do me a favor. Skip to that last page. Oh, no. Good. This is one. This is what I was looking for. All right, so what would I do here, guys? It says here's a ratio, right? Here's a ratio. What is the value of r? Now look at what it says. It says it's placed in the form q of x, where q is the quotient, plus r over x minus 9. Which of the following values is r? So what does r stand for in this case? Remainder. So if I just want to know the answer to that question, what am I going to do? I'm just going to synthetically divide it to see what happens, right? So what goes in the box? 9 goes in the box. And what do I have as numbers? 1, -11, 22. What do I got? I got a 9, I got a -2, I got a -18, I got a 4, and that's my remainder. All right, so what types of things would you use the remainder for? Well, the biggest one is going to, the remainder theorem for. The biggest thing, Giovanni, is going to be something like this, right? Something like this, where I literally ask you, is something a factor, right? Is something a factor? Now, what does this question say specifically? It says simplify the following using long division. So it is possible that they could tell you that you have to use long division. Are there cases where I have to use long division besides if they tell me? Yes. And that's if I'm dividing by something that is not what? Degree 1, right? Degree 1, okay? If I did long division on this, what am I going to do first? The first 2 numbers. Can I divide those 2 things? What do I get? 3x. Where does it go? Good. So that was my divide step. Then I'm going to multiply. What 2 things am I going to multiply? 3x times x plus 4. What do I get? 3x squared plus 12x. And where's that go? On the bottom, yeah. Then what do? And I subtract. And this is the step that I know a lot of you guys had trouble with, right? So that's why I'm going to say it again. Make sure that you're distributing your minus sign. I have 3x squared minus 3x squared, which is 0. I have 7x minus 12x, negative 5x. And my last step is to what? Bring it down and repeat. Drop it and repeat. So down comes the negative 20. And so then what do? Well, you ask yourself, does x now go into negative 5x? And the answer is, it does negative 5 times. So I take the negative 5 and I multiply it by x plus 4, right? And I get negative 5x minus 20. What am I supposed to do with the negative 5x minus 20? Subtract it, which means negative 5x minus 20 minus the negative 5x minus 20 will give you 0. So what does that tell me about x plus 4? X plus 4 is a factor because it divides into the polynomial evenly and gives us a remainder of, yes, dot, dot, dot. You guys just said it all. Okay? Because it divides into the numerator evenly, and I know that because the remainder was 0. Now, quite frankly, guys, if you do it this way, you're kind of out of your mind because I think that synthetic division is far easier. All right, but it's a good skill to have. Go ahead, do A, B, and C. All right, let's see how we did. Ready? First. Yes, no, yes? Remainders of 0, 3, and 0. Easy to make mistakes with adding and subtracting. multiplying, signs, things like that. Just try to be careful with the signs. Is okay with that? Last two. How would I handle this problem? I have four possible values of A. Which of those would be a factor? Well, guys, this is super easy to make a mistake on, okay? These are values of A, correct? What does this say? I want to know values of x minus A that work. So if A was -2, what would this actually say? Yeah, it would say x plus 2 because the negative minus the A would make two negatives, right? So this would be a factor of x plus 2. This would be a factor of x minus 2. This would be a factor of x plus 3. This would be a factor. Oh no, it wouldn't. Sorry. X minus 3. This would be x plus 3. And then what would I do with those things? I would take them and check each one to find the one that gives you a remainder of 0. Yeah. All right. I'm gonna skip that. Is that okay, guys? You know what you need to do, right? Check each answer, okay? Giovanni, this goes back to what you were saying a few seconds ago. You said, is 3x minus 2 a factor of this? And you said, well, I just changed the sign of that. But I said, well, don't think of it that way. Think of it as I need the root. And how do I get the root? I set it equal to 0. So in this case, it's not just what? It's not just changing that sign. It's also dividing by 3, right? So here in the box would go the fraction 2/3. You see why I corrected you on that now? Yeah, so don't just think, change the sign. Think set equal to 0. So I have values of 3, 7, -18, and 8. Guys, what's 2/3 of 3? 2. Seven plus 2 is 9. What's 2/3 of 9? 6. That gives me -12. And what's 2/3 of -12? It's -8. 2/3 of 12. 1/3 would be 4, which gives me 0. So is it a factor? Yes, it is a factor. All right. So guys, my hope is that you're finding that this unit ties a whole bunch of loose ends together. And we actually did quite a bit of review just doing today's lesson, didn't we? All right. I'm going to give you the rest of the time today, guys, to work